Mastery quiz number 14, Advanced Algebra through Data Exploration. Problem number 1. For a given population of high school basketball players, their mean weight is 160 pounds with a standard deviation of 10 pounds. If we select a basketball player at random and he is heavier than 70% of the other players, how much does he weigh? This is a go backwards problem. So the first thing we need to start with is the picture. 70%, change it to a decimal, okay? Heavier than 70%. So he is above average. So that means that's going to be to the right. 0, remember, is in the middle, so that's going to be to the right of 0. So this area represents 70% or 0.7 or 0.70. We need to figure out what this z-score is. You have two options. You can either use the table. If you use the table, you need to find the 0.7 inside your table. So, looking in your table, we have 0.6985 and 0.7019. Now, which one is closer? Okay, well, that would be the 0.6985. So, our z-score is 0.52 based on the table. If we use the calculator, we can use the inverse norm and put in the 0.7. So let me show you that quick. So again, second vars. This one's number 3. So we want the area to the left of that spot. Again, you don't see all of this information. You've got an older calculator, so this is what you should see when you are done. Hit enter, and you can see it's the same thing. It's just a few more decimal places, 0.52. Now, remember, z equals x minus the mean divided by the standard deviation. Well, we just found z, so we put 0.52 equals. X is what we're looking for, folks. How much does he weigh? That is x. Minus the mean. Well, it tells us the mean is 160 pounds, and the standard deviation is 10 pounds. All right, again, this is a go backwards. So we're going to start with the 10. Instead of dividing by 10, we're going to multiply. So 10 times 0.52. Instead of minusing 160, we're going to add 160. So you could write that out. So we're going to go 10 times 0.52 plus 160. All right, take your calculator. Go 10 times 0.52 plus 160, and we get a weight of 165.2. We're just going to say 165. So, if a person is heavier than 70% of the other players, this person weighs 165 pounds or more. All right, problem number 2. The following data is a random sample of grocery store shoppers and the amount of money they spend on groceries in a week. Based on the data, what proportion of shoppers spend more than $180? Step 1, type the numbers into list 1. For convenience purposes, I've already done that, so I have the numbers in list 1. Step 2, go stat, calculate, pick number 1. Again, all you have to do is hit enter, and voila, you have your mean. Remember, mean is the first one. That's the mean of that data set right here. And then the standard deviation, we're going to use the S, which is 34. So let's write those down. So the mean equals 126, and the standard deviation equals 34. All right, so based on the data, what proportion of shoppers spend more than $180? That's our x. The 180 is our x. So we got to go z equals 180 minus 126 divided by 34 equals, well, 180 minus 126 is 54 divided by 34. Now, 54 divided by 34, we get a z-score of 1 point, we're going to round it, 1.59. You should go 2 decimal places, because if you use the table, you've got to go 2 decimal places. All right, we're going to draw a picture. Doesn't have to be fancy. Zero's right here. 1.59 is to the right. Okay, now which way do we shade? It says more than, so we're going to shade to the right. All right, I'm going to do the calculator first this time. If we're going to use the calculator, we're going to go n normal CDF. Lower bound is 1.59, comma, and then upper bound, we're going to use 100 because it goes on forever. All right, go back to the calculator. Second vars, this time we pick number 2. And again, the lower bound is 1.59. The upper bound, we're going to put in 100. When you're all done, this is what you should see. Hit enter. Voila. We're going to round it. 0.056. 0.056. And if we change that to a percent, that would be 5.6%. Same thing if you use the table. Okay, so we're going to go to 1.59. Here's 1.5. Here's 0.9. We're going to go all the way across. We're going to come all the way down, and we see that it's 0.9441. Now, remember, that's the area to the left, 0.9441. So you need to remember to subtract that from 1. So 1 minus the 0.9441. You get 0.0559, which is the same as what we did on the calculator, and we're going to round that. So that'll be 0.056 or 5.6%. Okay, now we can say that 5.6% of shoppers spend $180 or more. All right, problem number 3. Here our z-score changes a little bit because we're dealing with a sample size. So we got to do a little bit more work here, okay? Not too much. So suppose the x has a distribution with a mean of 40 and standard deviation of 12. If a random sample of size n equals 36 is drawn, find the probability that x is between 37 and 43. So we got to do 2 z-scores. So z equals, okay, this is our x, our first one, 37 minus 40 divided by, now the standard deviation is 12 divided by the square root of 36. Okay, plug this into the calculator very carefully. Use your grouping symbols, use your parentheses, and you should get negative 1.5. Do the same thing with 43. So we're going to go 43 minus 40. Again, use grouping symbols. 12 divided by the square root of 36. And you should get 1.5. Draw your normal curve. Negative 1.5 is on the left. Positive 1.5 is on the right. We want to know what the area is or what the probability is in between. Remember, area and probability are the same thing. If you're going to use your calculator, use NCDF, negative 1.5, comma 1.5. Okay, so negative 1.5, 1.5. When you're all done, this is what you should see. So 0.866, we're going to stop there, 0.866. 0.866, which is approximately 86.6%. Okay. If you use the table, again, look up the positive one first, 1.5. I've kind of got it covered up here. Okay, 1.5 is right here, 0.9332. Okay, I'm going to write that down. Let me make some room. 0.9332. Then I'm going to look up the negative 1.5. Let me go back. Negative 1.5 is right here. That's 0.0668. So I'm going to put 0.0668. I'm going to subtract them. So 0.9332 minus the 0.0668. And we get, again, 0.8664, which is the same as we got when we used the calculator. That's it. 3 problems. Good luck.